Okay. Hi everybody. So today I will make a tutorial for how to extract and convert CMIP6 GCM NetCDF data and convert it into Excel file. So let I share my screen here. Okay. Okay. So this is I will show you this. When we download our NetCDF file from CMIP6, we will get this NetCDF file. This is rainfall PR, the daily rainfall for model Thai ESM1, the historical data from 1950 to 2014. So the file format is NetCDF and .nc. So what we want to do is we want to convert this NetCDF file into Excel file like this. So once you convert the data, you will get the Excel file like this for the location that you want to put your dataset. So at first, before we start with our tutorial, let me show you. First, you need to have your grid data. Grid dataset is what I mean here. For example, I'm using this one. This is the matchup catchment. I use this CHIPS dataset. CHIPS dataset with 0.05 resolution. So it cover all the 38 grid point in matchup in Sungai Benut catchment actually. Sungai Benut catchment. So the study is about matchup dam. So that's why I give the name is matchup. So you must have let long of your area, let long, and the grid let long and put the grid number like that. So for me I have like as you can see here 38 grid point for Sungai Benut area, and the grid number you put the grid from 1 until 38 here for the third column. So you prepare this data set, but if you have your station data, you can put your station data. But right now what I'm doing is I want to extract the data set. So I will extract like this. I have, for example, chips 38 bit points of chips dataset, and then I want to convert this dataset. I want to extract CMIP6 data based on this 38 grid point. 38 grid point. So the CMIP6 data will have different resolution. It can be 1 degree resolution, 2 degree resolution, depend on the model that you use. But I will convert this CMIP6 data into 38 grid point with the same resolution with chips dataset, which is 0.05 degree. So once I'm convert chips CMIP6 data, it will also become 0.05 degree, similar with chips grid point. So I'm using bilinear interpolation. So this have 38 grid point. Maybe the original CMIP6 data, they only have 4 point or 8 point. But I'm interpolate the CMIP6 data into 38 grid point, similar with the chips grid point. Okay, so that is how I'm extracting the data set from this chips CMIP6 into similar grid point with chips dataset. So first you must have your let long of your dataset, observed dataset, and put the third column grid, and then give a number from 1 until 38 until the end here. How many grid point you have? 38 grid point. So this is the code that I have, that my research group have prepared. So what you need is, first you need to install the library rgdal, this library rgdal, and then you install the library NetCDF4, and then you install the library raster, and then you install the library impute, and then you install the library sp. So you need 5 of this library to be installed. So, and then you clear the memory rm list here by using this code. Rm list equal to ls list memory, put the memory limit size to 196,000. So make sure that your workplace have enough memory. And then you locate your shapefile of the observed data set just now. For example, I'm using CHIPS dataset, which has 0.05 resolution. So I put the dataset in this folder. So you just copy the address up here, copy the address of the folder, and then you set working directory into your address where you put your CHIPS dataset just now. So now I'm so the name of this dataset is matchup grid. So the name of this dataset just now is matchup grid, which is this data just now, which have 38 grid point. After that, I'm extracting column 1 and column 2 and call it post. So column 1 and column 2, I will extract for this CHIPS dataset just now, which is the lat long of this CHIPS dataset. And then I put another one, this one, another, I read this matchup grid again, and then I make a raster from XYZ. So I rearrange the CHIPS dataset into longitude first, and then latitude, and then grid point, something like that. So you first combine the longitude, latitude, and then the number of grid just now. Okay, you prepare this. This is just to arrange your data properly. Later on, so that we can extract it accordingly with the CMIP6 data. So we have properly arranged our observed data here. And then after that, we locate the GCM. Where we put our GCM. So I put my GCM here. This is copy the address. This is where I put my GCM just now after I download it from CMIP6. So just copy the address folder, and then you put it, set working directory here, and then use list file pattern.nc so that it will read only the nc file in this folder. So that is the purpose of this code just now. So I put the name of this nc file will be fln, and then list.file pattern is equal to .nc, so that you will only extract the nc file. So it will detect the nc file. After that, this is the code to extract the nc file. So for all the length of the data in the folder just now for MIP6 data, you write then break, use the break function. Use the break function for this all the nc file, and then write stop if not equal space equal to false, not true. put it false, F. So from here, we can just start reading, run the code for the observed data, and then locate the NC file, and then this one will show you the information of the NC file, and then so that you know the resolution of the NC file. This from this code, from this line of code. After that, this is why we use a CHIPS dataset. We make a resample. Resample we make by using bilinear interpolation. The method that we use is bilinear interpolation because the NC file, I run this first. It's, you can see. Oh, it's still running. So when we run this code, it takes quite some time. Depend on the power of your laptop also. If your laptop is not very powerful, it can take some time. And if there is a lot of NC file, a lot of file that you want to extract, so it can take longer. It might take longer. Depend on the size of the NC file also. So from this file, we have 2, 3, 4, 5, 6, 7. So we have seven NC file, because when we download CMIP6 data, it's a part by part. So right now, we extract the data and then we combine all of this data also. So you will end up with only one file instead of 7 file, and then you need combine it later. But here we combine everything in one go. So now it has extract up to 5 file, and now we are left with 2 file. So the file will be for 2015. This is 19. I think, yeah, 1950 to 2014. Depend on what data that you want to extract. Okay, now I have run this code. Now I show you this code just now, pre here. We can check the resolution of the NC file, of this NC file, which is a Thai ESM1 model. So we can see here the resolution of the data of this model is 1.25 degree X and Y, and 0.94 or something like that degree. So we know the resolution of this dataset. Now the resolution of this dataset, we want to interpolate it with the CHIPS dataset, which is this lat long. We want to interpolate it into 0.05 resolution, so that we will have a homogeneous data. So we use bilinear interpolation, and then just follow this code, that raster 2 point. So the data from this resolution, it will go to the point of the CHIPS dataset. After that, we combine this one, merge, which is we merge the data long, lat and long just now. We want to combine it, lat and long, and the result from the interpolation by using bilinear interpolation just now, by using this code. And then we combine the data, and then we will get this one after we resample just now. I can show you the result for resample here. After resample, from this data set, we resample it into 0.05 degree. It will become to 0.05 degree only, and it will within this lat and long of our data set. That as you can see, this is the lat and long, the data. So this is the lat and long, the extent of the data here. After that, we combine the data that here, combine it with the data that we have interpolate, and then you will get this result here. It will show you let and long, and long and let, and then we have this result. We have extract the raw data. This is the raw data. As you can see, the raw data, it looks like this. It's like transpose like this, from left to right, from 1950 here, and if we go further here to the right, it will go until 2014, and then the let long is here. But we want to transpose it later on, this data set, and we want to convert this value into a meaningful rainfall value. After that, we use this code, we make a round, because this data set just now, they have so many point zero 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 something, very long. First, we convert the rainfall data, the raw data from NC file. This is how you convert it. You must times it with 86,400, and then you will have a rainfall in millimeter. So rainfall unit will be in millimeter when you times this one, and then we want to round it into with 2. So we run this code. You see, from the initial value just now, we recalculate the value of the CMIP6 and convert to millimeter. After we convert to millimeter, and we make round it's 0.00, like 2 round 0.00, so that you can look the daily data. We already have the daily rainfall data from NetCDF, and you can see the result here. After that, we change the heading name, because this just now it's changed again, the heading name here. It's we transpose also the data just now from white into vertical like that. So on the left here will be the date, and then here will be the grid point. The column will be the grid point. The row will be the date, the day. So we want to change this V1, V2, V3, V4 into the grid point that we use. So we just use this column, just paste something like that, call names and change it, and you will get this grid point that we have interpolated with the chips grid point just now with 0.05 resolution. And then just set your working directory and write your data into Excel CSV file, and then give the name of the data set, and then you will have this result. So you up here, the heading, you have the grid point location, let and long. This is the let, this is the let, and then long and let here, up here. And then on the left here, you have the date along the row here. So this is daily data. So you have rainfall in the Excel file in millimeter. So you just run this code just now, write in CSV the data set here, tdate, this tdate, and then write it into CSV. So this is the process of how you can convert the NetCDF file from this file just now, NetCDF file of CMIP6, and convert it into Excel file, so that later on you can use it or make all other analysis that you want. So I think that's all for me today. Thank you for watching. If you have any question, you can put it in the comment below. Thank you for watching.